partition the zoo. So let's jump straight into it. There is a zoo with n animals of different kinds represented by the string A. Each kind of animal is represented as a letter from the lowercase English alphabet. Right? So this essentially means that there is a string A of length n, and each different kind of animal is represented or is mapped to a single English alphabet. Now, what do we need to do? We need to partition this string /zoo into two zoos at index k, such that the first zoo contains the animals from a of 1 till a of k, and the second zoo contains animals from a of k plus 1 till a of n, which is the end of the string. Right? And what is the constraint under which we need to make this partition, or what do we need to optimize for? We want to optimize this cut such that the partition divides this into two partitions such that the common number of distinct animals in both zoos is maximized. Right? So if we take the two partitions, we figure out what are the distinct characters or / animals in both partitions, and then we compare the left side of the partition and the right side of the partition, the two partitions, and then we check what are the common animals between both the partitions, and this number has to be maximized. Right? Let's take an example and understand what this essentially means. So here, let's say the sample input, the first line gives you how many animals are there, and the second line gives you all the animals. Right? So the animals in this case would be ZZ, TT, TZ. Right? Let's look at how to solve it now. Right? So ZZ, TT, TZ. Right? This is the zoo, and each of these are the animals. Right? So where are the possible places in which we can make this partition? Right? Where we mentioned we can make partition at kth index. Right? The value of k can be either 0, 1, 2, 3, 4, or 5, or even 6 for that matter. Right? So let's understand, we can split this string in these many ways. Let's understand, if we split it in each of these ways, what would essentially be the common distinct elements between both partitions. That's what we need to understand. So let's take this partition here. Right? On your left, you will have no elements, and on your right, you will have all the elements. Right? But if we take the distinct elements, it will be Z, T, and C. And what is the common element between these two? Nothing. Right? So the answer in this case, if we have to partition here, would be 0. What would be the answer if you have to partition here? If you have to partition here, left would be Z, and right would be D, T, and C. Right? Because if you have partitioned here, left you will get Z, and on the right you will get Z, T, and C.
Started with.
Now the common elements between these two sets or partitions would be Z. Right? So in this case, the answer would be 1. Right? If we have to take this partition, right? You have again on the left you have Z from these two elements, and on the right you have, let's take T is one element, T is another element, and this Z also comes here. Right? Again, we can see that the only common element is C. The answer is 1 again. So let's scroll down. Okay. Now, if you have to come to the third element, which would be here. Right. If you split it there, then essentially your left elements will be now Z and T, and your right elements would be T, T and Z. Basis here, because you have this T as well after that comes, and C and Z. So now if you take a look at the common elements, right? Now the common elements would be Z here as well as T, which would be 2. Okay. So till now we have gone through 4 iterations, and in these 4 iterations 2 seems to be the max number of common distinct elements between 2 partitions. If we split the partitions into 2 here, if we split it here, you will have Z, Z and T, where the distinct elements will be Z and T, and on the right you will have T, C and Z. Let's go one step further. If we go one step further, you will have left distinct elements as Z and T, and right distinct elements as T and Z. Let me just write the letters here again so that there is more clarity. E, Z, Z, E, 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 Z. Right? So now we are at what point? We are at this point. So the distinct elements here would be Z and T, and the distinct element here would be C and Z. Right? Again, now if we compare the common elements, we essentially get Z here, and that's the only distinct common element. Right? If we go to the next step now, you will start seeing that again what we faced here has started happening here, because there aren't enough elements on the right anymore. So here you would have, on the left you would have these T as well as C, and on the right you will only have C, and at the end you will have no elements on the right and all the elements here. Right? So this was also one common element, here also one common element. So obviously the answer is 2 in this case. Right? So what did we essentially do here? Like in all of this code, all we did was to figure out if a letter comes before the partition as well as after the partition. That means that the element exists in both partitions, and therefore it will increase the number of common elements in both partitions by 1. Right? That is how our intuition told us that 2 would be the right answer. Now, what we essentially need to do to solve this problem for any input or for any length of this thing is simply to determine if I partition at index k, what is the maximum number of elements that will exist both on the left side of it as well as on the right side of it. So this is the intuition that we have to be solving for. So let's take a look at how we can solution this out via code. Right. To summarize what we have learned so far, we have learned that we need to go through every possible partition, and then we need to figure out wherever I partition, what is the total number of letters that are common to both sides of the partition. Now, what is a good way of doing this? Let's explore this approach called building prefix arrays to make our life easier to solve this problem. Right? What are prefix arrays? Let's try and understand this using one of the examples from this test case. Right? So let's take the example of Z. If I have to build a prefix array for Z, what does it essentially mean? Prefix array is essentially give me how many Z's have appeared in the index before me. Right? So, for example, if you have to take the partition here, how many Z's are before this? It would be 0. Right? How many Z's are before this partition? It would be 1. How many Z's are there before this partition? It would be 2. How many Z's are there before this partition? Till 2. Right? Before this partition, 2. Before this partition, till 2. And before this partition, now there will be. So this would become a prefix array for the letter Z for this string that we have. Right? So why is this useful? It's useful because it allows us to solve for the problem that we just discussed. Right? How do I know at each partition whether there is a Z before as well as after? Right? So now what is a good way of figuring this out? From this prefix array. Right? What we essentially need to do at any partition that we have is, let's take this example. So this partition would be mapped to this index, right, in the prefix array. So here what it's essentially saying is that if I pick this partition, there are 2 Z's before, right? And now if I have to go through the prefix array to the right, it essentially means if I take this partition here, there are 3 Z's before this partition. And there are 2 Z's before this partition. So essentially, what do I have to do to figure out whether there is a Z before and after is just if I figure out this value is greater than 0, which means that there is a Z before, and if I subtract this value and this value, right, which means that there are 3 Z's at this point here and 2 Z's at this point here, which means that there has to be a Z between here and here. So it will become 1Z, which is the 1Z here. Right? So this just makes it simple that at every partition, whether there was a letter before and after, which essentially simplifies our problem to say that if I go through every index and I check for every letter, not just Z, for letters A till Z, whether this condition holds true, right? 2 conditions, whether the value here is greater than 0 at the prefix array, and value of n minus whatever we had considered here, this value and this value, if it is greater than 0, that essentially means that there is another Z after the partition or another letter after the partition. So if we repeat the same process for all letters A to Z at every partition and check amongst all the partitions, what is the total sum of all the letters that apply to this condition, which is they appear before the partition and after the partition. So we will have one value for each partition. Let's say that can be 3, 2, 4 and so on, and we just need to find the max of all of these numbers and we will have our answer. Okay, so coming to the implementation now, what do we essentially have to achieve? Right, first we would need to transform the string into an array so that we can easily iterate through it. So let's take this array S, where we can split animals, as we know this JavaScript function which splits a string into an array. So we get let S equals animals dot split, which will be an array. After this, we need a pre-filled 2D array, essentially where the rows represent all the letters from 0 to 25 index, where 0th index will be A and 25th index would be Z, like we have discussed before, and J or the columns will be represented as each value of K or each possible partition. So let's also initialize that. Let's call this pref, which would be pre-filled 2D array. Now number of rows would be 26 and number of columns would be n, which is the total number of animals slash the total number of partitions possible. Right. So now what do we need to do? Now we need to build the pre-fill array for all the possible letters at every partition. So we will go from I equals to 0 to I less than n, which will represent every partition, possible partition, right? So what do we need to do here? Let's take this case of Z that we have just discussed, right? So in this case, let's say Z ka index would be 25, right? So in the 25th of the 2D array, so you will have, let's say, array 0, array 1, and so on.
Come sound karo Manish.
Till you have the 25th
Come sound karo.
array, which would represent what is the prefix array for Z. This would be for A, right? And internally, it would be for each value, each partition. This partition, this partition, this partition, this partition. There would be one value each, like this. Essentially, to achieve this, what do we need to do? Like we discussed before, we need to first figure out whether a Z exists in that index or not. So that would become Z ka, the letter ka index.
Come sound karo Manish.
Which would be the alphabet index. So what is an alphabet index? Like we have discussed, 0 for A and 25 for Z. We can just achieve this using this helper function, right? So we say get alphabet index of
Sound nahi
S
karta
of
bhai,
I,
dekho.
where S of I would be each letter. For example, in this case, this would become Z, Z, E, Z. So in this case, I would be equal to 0 in the first iteration. So we are picking the letter Z. And we would need to make that I plus 1 and increment that value. Why? Because like we have discussed, for this index, this is the partition. And for this partition, we need to say that there is one Z before. Right, which is the reason we are doing I plus 1, because we are cutting the string into A of 0 to A of K.
Video खुला है
And
हवास
A
में
of
गलत
K plus 1
घूम कर
to A of N. Right? So whenever I am evaluating an index, I am checking what should be the value if I place the partition after me. Right? Therefore, for this value, I am going to add 1 as the prefix value. Right? So it would be I plus 1 plus plus increment, suggesting that we need to increase by 1. Right? But we have also discussed that if the value here is 1, right, the value here should become 2, because we have already encountered one Z here. We are encountering another Z here. So to add that logic, what we just do is for every iteration of S, we just say that we will also loop through all the letters once. Right? So J less than 26, J plus plus. We just say for every letter, we will make sure that value with the previous index is getting carry forwarded at least. So if it was here 1, then it would be 1 here as well to start off with. Right? So we would say pref of J of I, right? And then we would increment that value by 1. So let's again go through this logic just for this case. Let's start over. Right, you have z, 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 z. So what you essentially did was initially you attributed, if we go to this logic, let's say I equals to 0, we have picked z for the first time. We went through all the letters. Pref of j of I would always be 0 because we have pre-filled it to be 0. So nothing really happens in this case. But when we come here, we get alphabet index of s of I, which would be z, where we would get the value 25 here. So we go to the 25th array of the 2D array, right? And there we say this would be 25 and I plus 1, where I is equal to 0 here. So we would set ref of 25 1 equals to 1, right? So that would be this index, right? And then when we do the next part, right? When we do the next part, what essentially happens is when we come to this part, when I becomes 1, now we have picked this z, right? What essentially happens is when it comes to this inner loop, we again go through all the letters, but now I equals to 1. So what essentially happens is pref of 25 of I plus 1, which here would be 2, will already be set to 1. Right? So when we come to this again we have another z. So again we'll get a 25, and I plus 1 now would be 1 plus 1, 2, whose value will increase by 1. Right? So when I'm calculating for this partition now, what essentially has happened is there is already a 1 present, which is getting carry forwarded from here, whose value will increase by 1, making it 2. Right? This is essentially what we need as well. So that way it is sorted. Right? So now what we essentially have is we have all the letters, and we have what is their prefix array for each letter against every partition that exists in our array. Right? So now all we need to do is loop through this and get what is the max result. So let's go through them again. Hello everyone, is that if I pick this, because we are cut 1, what is their prefix array for each letter against every partition that exists in our array. Right? So now all we need to do is loop through this and get what is the max result. So let's go through them again. So we would start with I plus 1 because we have already realized in the first iteration all values are set to 0 because it comes after the first index, the first partition. And we will go till n as the range. So we'll have to say I less than n plus 1. This would be I plus plus. And we'll go through every letter. Right? So that would be j equals to 0, j less than 26, j plus plus. So this represents every k, right? Every partition. So let's maintain a temp result here, right? Which would give us the total common distinct elements between two partitions for every iteration. And we need to get a max of this result. So let's also add that. We'll say result is math.max of the temp result as well as result. So if there is a temp result that's greater than the result, it will keep updating. So once we have this, we just need to stitch in this logic that if there is a value between here and here, as well as the same character can be found here till here. Like we have discussed, the way to do that would be to get the value here at this partition, make sure that it is greater than 0, right? And to get the value at this position, right, and subtract it with the value at this position. If that diff is greater than 1, which it means it's greater than 0, it essentially means that there is at least one letter of that of the letter that we are considering in this partition as well, right? So how do we translate that into code? We say if ref of j, which is the letter, which represents the letter of I plus 1, because we're getting the partition, is greater than 0, and ref of what is the way to check whether it will be the last one, it would just be n, right, which would be this. We're getting this. What is the prefix array value at this point minus prefix array value at the partition, this, right? If that is also greater than 0, so this would become the left hand partition, this would become the right hand partition, right? If both of these cases are true, then for this specific letter, temp result is incremented, right? So once this happens for every letter, we will get to know at this partition value k, what will be the total number of common distinct elements in each partition or in both partition. And once we iterate over all the possible partitions here, and here, we can compare each iteration's value, right? And if anything is greater, we update that as the result, right? So now once we get the result, we just let's console log the result, right? Right. So one other thing that we need to fix is that this has gotten out of our main method. So let's just put that here. Right. So I think now we are all good to go. Let's run the program, see if the value that we expected, which is 2, will be returned. Right. So the value is 2 and our logic has worked. Right. So I hope this was useful for everybody, and I was able to help you understand these concepts of how to pre-process using prefix arrays, and then what would the logic be following our intuition that there needs to be a letter before the partition as well as the partition, and what is the best way to get at it. Thank you so much.